Okay, for question 8C, we are looking at the distillation setup. So we have compound A and B in a fractional distillation column, and the question says that A was found first in the distillate. Okay, so quick recall on your general science concept. The distillate that appear first will be the one with a lower boiling point. So what the question is trying to tell you is that, okay, A has a lower boiling point. Why does A have a lower boiling point than B? So quick comparison between A and B is that you notice that A, the OH group and the NO2 groups are actually quite close to each other, whereas in B, OH and NO2 groups are far away from each other. So if we were to draw the structure of A out, so we have a benzene ring. Okay, of course, at this moment, you don't know what's a benzene ring, so we just ignore this part. We just treat it as a carbon chain, right? And then we have our NO2. So recall NO2, it will involve a dative bond and a double bond. Now, so from this diagram, you can see that in A, the OH group, you have a hydrogen that's bonded to a highly electronegative element, oxygen. So you have a delta plus H. And on the NO2, you do also have lone pairs on the O. And this, therefore, can result in what we call intramolecular hydrogen bonding. Okay, so the hydrogen bonds happens within the same molecule between the NO2 group, the oxygen of the NO2 group, and the H of the OH. So what you have is you have a hydrogen bonds within the same molecule, whereas in B, if you take a closer look at B, these two groups are far apart. Alright, so this OH cannot intramolecular hydrogen bond with this NO2. So in this case, the OH group therefore can intermolecular hydrogen bond with another molecule. So let me consider drawing another example, another molecule next to it, so you can see this better. So imagine if I have another molecule B here, I have a OH here. Okay, I draw in the benzene ring. Okay, I have my NO2 is on the other side. This is CH3. NO2 is here. Right, the lone pair on this oxygen can now participate in the hydrogen bond between another hydrogen of another molecule. So comparatively, this is what we call your intermolecular hydrogen bond. So what's the main difference? One is inter, the other one is intra. Intra is within the same molecule, inter is between two different molecules. So the question now is, what affects boiling point then? The boiling point is the extent of intermolecular hydrogen bonding. So the main difference in the case of A has intramolecular hydrogen bond and therefore cannot have much intermolecular hydrogen bond, whereas in B, it cannot have intra and therefore it has more inter. Okay, so how then do we phrase our answers then? So in A, the OH and NO2 groups are close to each other, intramolecular hydrogen bonding happens. So as a result, notice the effect on the intermolecular hydrogen bonding. So again, focus on boiling point, melting point, we always look at intermolecular. So if you have more intramolecular hydrogen bonding in A, you therefore have less intermolecular hydrogen bonding in A. Because now this H can no longer participate in another hydrogen bond with another molecule, right? So as a result, the hydrogen bonds in A, intermolecular hydrogen bonding in A will be less extensive, and therefore less energy is required to overcome the intermolecular hydrogen bonds in A compared to in B. And therefore, boiling point of A will be less than B, and A will therefore be distilled out first. Okay, so in such a question, when we are comparing between intra and inter, it is important for you to analyze the relative positions of groups that can partake in hydrogen bonding. You notice that in my analysis, I did not really focus on CH3 because although CH3 has a H, but the CH3, although it has a hydrogen atom, but the H are not bonded to F, O, and N. For hydrogen bonding, alright, importantly, we need to focus on H bonded to F, O, and N. Second, we look at lone pairs of electrons on F, O, and N. And this is why at the start, notice I only focus on these two groups because I know there's a H bonded to FON here, and then there's N and O with lone pairs on it. Alright, so that's why I immediately zoom down to these two groups instead of focusing on the CH3 group. Okay, with that, we are done with this question.